Hi everyone, so this is my lab 1 analysis for Physics 2212. Starting here with introduction, so the purpose of the lab was to find the excess charge on a piece of Scott tape, and I use glow script for this. The various physical formulas are going to be discussed further, and the result of this lab showed us the difference between an ideal physics world and a real physics world. So in terms of the equations used, I use Fg, which is force of gravity, which is m times g, Coulomb's law, which is kq by r squared times r hat. From Coulomb's law, we also know that the charge that like charges repel and unlike charges attract, and the charge on each proton or electron is plus or minus 1.6 into 10 raised to minus 19. In terms of the experiment here, the setup was two pieces of glow script, and the system in this case was the U tape that was ripped off, and surrounding was everything else. So we started by having two U tapes according to the lab instructions, placed one on the top of the other and ripped one of them off, and then make conclusions about certain properties. Further on, we individually created a glow script model to estimate the amount of charge, and the results are discussed forward. The results here are, so just to reiterate, the system in this case was the tape B and the surrounding was tape A, everything else, and the cavity. Initial condition was the length was 0.2 meters, mass was 2 into 10 raised to minus 4 kgs, and force of gravity was 0.00196. So analysis, the distance between two tapes was 0.032 meters, and the tape charge was positive as it got attracted to a pen which was negative. As we discussed earlier, unlike charges attract and hence the positive negative match here. So the coding portion here, as you can see, the various codes has been shown here. How this model actually works is we are setting gravity equal to the force of electricity, and hence we can write the charge on tape A as force of electricity times r squared divided by k, which we already know. So the result of this was 1.4941 into 10 raised to minus 8 Coulomb. Going forward, here is the computational model I used. So the orange ball is tape B, the blue ball is tape A, white arrow shows the FG on tape B, and red arrow shows the FE on tape A by tape B. And the green arrow shows the electric force on tape B by tape A, as you can see here. Finally, analysis. So there are a few assumptions that we made that we are ignoring air resistance. We are treating the long piece of tape as a single point charge, and we are saying that the charge is evenly distributed. However, I just want to make this clarification that this might not be possible in real life because air resistance could not be ignored, and we cannot always assume that the charge are evenly distributed. Errors, there's some potential errors, so TPNB could be affected because we're touching it with the hand, so charges might be affected there. Weight might be a bit approximation there, and not taking into consideration the air resistance, temperature, and humidity might have affected our results. Final discussions of what if. So if the signs were switched, there would not be any change in the observation because then both tape A and tape B would have net negative charge and which will still repel, causing a floating effect. So all the findings would remain the same if the charge was changed. Also, an important factor here is to make sure that we handle the charge tapes as little as possible because with human hands or tables or any other objects, the charges might flow from one device to another, and this will affect the interaction between each other. So even if the entities are electrically neutral, they can be polarized, leading to some interesting behaviors. Conclusion, and here's my final thoughts that electric behavior around us is really fascinating. This is something I did not consciously observe before, but seems to be very interesting when I saw this from this experiment. Also, the interaction is not just limited to electrical particles. Electrically neutral particles can also be affected in terms of electric field and create interesting insights here. Yep. And that is my conclusion for this. Thank you so much for listening.